Hello, and welcome to part 4B of the Hive's PCB Design with KiCAD series. My name is Ben, and I'll be walking you through this process today. Part 4 as a whole has been covering the entirety of the schematic creation. In this section, part B, we'll be looking at how to locate device models online and how to create symbols directly in KiCAD if those aren't available. If you watched part 3, you might remember that in our design flow there was a project setup and library creation step, but due to the relative simplicity of this design and that library management was not covered during the original workshop that this tutorial is based off of, we're going to leave all of that library creation to part 6 and 7. However, I strongly advise you to watch those videos if you're considering doing design more seriously. Some of that will be covered in this video, but it's a lot more thorough in the other videos as well, although they are still relatively short. Anyway, let's jump into KiCAD. Before we get there, just a reminder of the flashlight circuit we're developing. Note that this image was taken from draw.io, so the symbols are a little bit different than you'll see in KiCAD, but still, it's the same circuit. And this is where we left off at the end of part 4A. We had all 11 symbols, all the standard components, and we were about to add the integrated circuit symbol. If you've forgotten anything that is, or you don't have a schematic that has 11 symbols on it, then I suggest you pause the video and add those, or at least skim back through part 4A or the associated PDF. So as I mentioned, adding the IC is the last step. It's different than the previous symbols for two primary reasons. First, the symbol itself is unique, or if it's not really unique, it's more that locating a symbol with an IC with the same set of pins and pin names that's already in KiCAD will likely be as much work as making a new symbol or finding a new symbol. So that makes it approximately unique. And second, the footprint may or may not be in KiCAD either. It's a standard package, so it might be, but we'd have to see later. So that's going to be a little bit different as well. It's always a good idea first to check if the component you're interested in, the device, actually happens to be in one of the built-in libraries already. So you should go ahead and open the Add Symbol window and filter for the RT4526. Did you find it? Totally okay that it's not, and I hope you didn't find anything. If you did find something, go ahead and pretend that you didn't, because it shouldn't be in there. But the next check is going to be to see if models have been already professionally generated somewhere. It's always preferable that somebody else, like that you trust, has generated these models previously, not you, partially because it saves you a lot of time, and also because it's much less error prone. They're much less error prone if a professional makes them rather than you, because that is their job. Sometimes you'll get on the supplier page, like on this DigiKey page, you'll get a ECAD models link where they'll actually store some of the libraries that you can download. Unfortunately for our part, sometimes they do not have that option. If the supplier doesn't have a link, we can go and look for them manually. Two places I've had good results with are Ultra Librarian and SnapMagic, which until like 2 months ago, which doesn't mean anything in this video, but until very recently, or late 2023, was called Snap EDA. Both require free accounts to request new models, but Ultra Librarian actually allows you to download pre-made models without one. SnapMagic has a few additional tools that are available for registered users as well, like an in-browser symbol and footprint generator. It also requires you to download, make an account to download or request symbols. But both accounts, as I mentioned, are free to open. We're going to arbitrarily start with Ultra Librarian. So this is what the homepage looks like. There's a big search box in the middle. Go ahead and search for the RT4526 if you're following along. Unfortunately, it might be different for you at this point since I've actually requested it already, but at this time the model didn't exist. The part was grayed out, and you can see the icons on the right are also unfilled as well. If they had any of the models, these would have been filled in red, but it doesn't look like it today. So instead, we're going to try to open the parts page by just clicking on the part name on the left. And that'll give us this window here where we can actually ask or request the models. You can request, you click either request button for the symbol or the footprint, and they'll generate both, actually. They may even generate a 3D model as well. The parts request looks like this. You just go ahead, make sure you're logged in and actually request it, hit the submit request button. For Ultra Librarian, the standard turnaround time is guaranteed within 48 hours. So that may or may not be too long for you. That's kind of your decision to make here. But you can always request it and then move over to the other option, or the other option I use, which is SnapMagic. SnapMagic has an in-browser model generator that's linked directly from their homepage here called InstaBuild. But while most standard like IC footprints can actually be generated, the actual physical layout of the part, what it actually looks like, the symbols are apparently only limited to select footprints as of the generation of this this tutorial. Although maybe that's changed now that you're watching it. We're not going to use that today, but I'll talk about them in videos 6 and 7 if you're interested. So searching for our part again brings us to this page, but be careful because sometimes they put like a recommended part at the top that isn't the right part. So that's not the right one we need. That's some sort of relay thing or DC-DC converter, which is not what we want. However, there's still no models available for this RT4526, and you can see that because they're empty. The filled one is for the data sheet, so it's not super useful for us because we can download the data sheet from wherever. So go ahead and click on the part to open the part page. This would also be where the in-browser, the InstaBuild link would be if it was available. Unfortunately, it's not. So let's go ahead and we can request now. Unfortunately, one of the big differences between Ultra Librarian and SnapMagic is that SnapMagic doesn't have a guarantee on turnaround time. So sometimes it'll be done in an hour and sometimes it'll be done in a week. It really just depends. So do keep that in mind when you're thinking about this. Great. But you get a cool ghost when you've requested the part. So, that's always kind of fun. So we struck out 3 times. What to do next? Well, we can keep searching around on the internet randomly. Maybe there are some other websites that you've used before that you're willing to try. But the returns are likely diminishing. There's only so many places that you're going to go to do this, and sometimes you don't really necessarily trust the models, and you're going to spend more time verifying the models than actually just doing it yourself. So instead, because this is a KiCAD tutorial, we're actually going to go ahead and make the symbol in KiCAD directly, and I'll show you how to do that. They're relatively easy to make and are much less prone to errors than custom footprints, but they can be tedious with many pins. So it's totally acceptable to wait for Ultra Librarian or SnapMagic to generate them, but it's totally doable to make them on your own as well. Unlike footprints, which can be a lot more of a pain. So back in the symbol editor, to make a symbol, we need to go into in the schematic view. To make a symbol, we need to go into the symbol editor, which can be accessed directly from the project window, that main project window that opens, or directly from the schematic using this icon here, kind of in the middle. Also looks like a little op amp with a little red circle and a check mark at its nose. So this is what the blank symbol editor window looks like. On the left are all of the available libraries that are available to you as the designer. You can manage which libraries are actually available to you under the project window under preferences. By default, all of the built-in libraries are accessible, but you could kind of down select if you didn't want to have that for whatever reason. Note that all the libraries the built-in libraries are all read-only, so we're actually going to need to make a new library for our own footprints. Units are on the top left again, as well as the grid scaling or grid preferences. On the right, we have text and drawing actions, and then on the right at the top, we have the new pin button, which will be the most used button in this generation. Because those pins are connection points for your device, so that'll typically be the most clicked on button here. As mentioned, we're going to need to make a new library to add our symbol into, since all the built-in libraries are read-only, and we don't have any writable libraries of our own yet. So let's go ahead and make that from File, New Library. You can also create a new symbol and add it directly into a library you've already made using the new symbol dialog, or you can click on N or that icon there. We're going to do that actually on our own in part 6 if you're interested. Oh, actually, I lied. We're actually going to do that very shortly, but that's fine. So new libraries can actually be set to have one of two scopes. They can be set for all available projects, meaning called global scope, or they can be available only for this project, which is called project or local scope. Project libraries can actually be made available to other projects by adding them manually through the main project window under Preferences, under Manage Symbol Libraries. I'm not going to cover that here, but just so you know, it is a possibility. As another aside about library management, which library management is a very important but underappreciated aspect of PCB design work, or at least it's underappreciated by beginning designers. There's a world of discussion out there about the best methods, especially considering backups and version control and cloud connectivity and different disciplines and groups. But for KiCAD, it's nearly always better to use a project scoped library than a global library. Why is that? So it's because global libraries are often not under your control, and they can change and fluctuate between software revisions as well as even within software revisions. And it makes transferring an entire project more difficult because you either have to find the global libraries and transfer and copy those over, or you have to hope that the path is the same on the other side. Therefore, it's strongly preferred to create a single project scope library and copy global parts into it. We've obviously not done that with this tutorial for a few reasons, and primarily because it adds a lot of time, and also it's a very simple design, so we don't really have to do that. If you'd like to understand how this process works in a real design, I do go through that, as I mentioned, in part 6, and then for footprints in part 7 as well. But based on all that, we're going to make this new library a project level library. So click Project and then hit OK. Save the library. Generally, I would save it as the same name as the project itself and in the project directory so that everything I have that's related to the project can be nicely zipped together, but it is totally up to you how you want to do it. So great, we can see the new library on the left in the libraries window already. So next we can create a new symbol just by hitting the N key, the icon in the upper left corner, or File New Symbol as well. So a little pop-up window comes up. Let's fill this window in. At the top, the part device name, or the symbol name. For chips, I usually use the part number, the entire part number. So I would call this RT4526. In this specific case, you can actually leave the GJ6 portion out of the name, because if you read the data sheet, those are actually the only 3 values or options, so the final 3 digits. And so it really doesn't it doesn't matter if you use them or not. Now, it's possible in the future they would add different digits, and then you could be a little confused, but for now, it's not really a big deal. If you're going to derive the symbol from, basically means you're adjusting or editing a known symbol, making a copy and adjusting it, then you could add that to the derive window here. The reference designator is important. It's a letter that KiCAD uses to identify all instances of this symbol or of a type of symbol. So each instance will get a number. So a resistor might be designated R5 for the 5th resistor in the schematic. U is very common for ICs, though you could choose something else if you'd like. It's fine also for multiple symbols to have the same reference designator character, like U or R. It just means they're all of the same type, and they'll just increment naturally throughout as you add more symbols. The rest of this window doesn't matter, so just go ahead and click OK. Since there's nothing in the editor now, it'll actually automatically zoom in on the reference designator, which is why we see this giant U. So that's better. Currently, the U is at the anchor point, which is the point at which the symbol will actually be attached to the mouse when you add the part in. We'll move both of these later. So as usual, the grid spacing and units are defined on the top left. So you should check the grid spacing first by right-clicking and go in a grid, it should read 50 mil or 1.27 millimeters. If it doesn't read that, you're probably going to be really sad later, because KiCAD in KiCAD schematics requires pins to be placed on that grid. Otherwise, you won't be able to connect to it. Wires only work on that grid. Personally, I usually select mils for my units because I'm used to thinking of hole sizes and trace widths in mils, and because I'm used to imperial units. But you can readily use metric as well. KiCAD is based on metric, so you'll see cleaner default values if you use metric. It's totally up to you. Note that mils and millimeters are not the same. Mils are also known as thou or thous, are 1,000th of an inch, 0.001 inches, whereas millimeters are, of course, 1,000th of a meter. So the approximate conversion is about 1 millimeter to about 40 mils, roughly. So if you remember that. So once the grid and the grid spacing and the units have all been done, the first thing I like to do is make all of my pins. So how many pins do we need, and what are they actually called? Let's head over to the datasheet. So this is the datasheet, page 1. We're looking for anything that ties pin numbers to a function. Usually that's going to be a table. It's not up here. But if you scroll down, it is conveniently located at the top of page 2. The physical location, which you might see in a pinout diagram, is not useful yet, and we're also not that interested in the pin functions this second. We really only need the number and the name. So back in KiCAD, if we add a new pin by clicking the top right icon there, the add pin icon, or just tapping the A key, you'll end up with this pin properties window. There are a bunch of options in here. Let's start with the name and number. If you forgot, having two screens, you'll notice that having two screens is very helpful. For PCB design, or frankly most CAD work, but PCB design in particular. You can also be a wizard with Alt Tab, whatever you like. So I've copy pasted the pin number and name chart on the right there, and I filled out the pin name as LX and the pin number as 1. Now electrical type is a little trickier. By default it's set to input, but there are a whole bunch of different options. So which one are we going to be? So we should go back to the pinout table, because I did not copy the functions, specifically because I said to ignore the functions. And if I read the function, switch node, open drain, output of the internal N MOSFET, connect this pin to an external inductor and diode. That doesn't really mean very much to me. I mean, it means something electrically, but it doesn't really tell me what kind of electrical type it is. And frankly, I'm not really sure what electrical type means at this stage, or you don't. So if you're not sure what it is or don't want to worry about it too much, your best bet is to set it as either bidirectional, unspecified, or passive. Passive is very common, like all of the default symbols use passive for all of their pins. If you choose something else, it won't cause the device to fail, because but it might cause you headaches with the ERC later, the electrical rules check later, because part of that is going to be checking for pin type matches, because technically each pin type is only allowed to be connected to a subset of the other types. Otherwise an error gets thrown. And we'll actually run into this problem later, and you'll recall this slide. But for now, you can set it to pretty much whatever you'd like. The rest of the choices here are just graphical, and we'll adjust those as needed just in the editor itself, so we don't need to worry about that. So just go ahead and click OK on the lower right. And then we can left click to place the pin anywhere on the sheet, because we're going to be moving them around later anyway. Notice that I set mine to bidirectional. Again, frankly, this is not super relevant. Great. All right, now I'm going to recommend that you pause the video and add the other 5 pins. I've left the the functional pin description table up here for you. So you should go ahead and just add those other 5. Awesome. So presumably you've added the other 5, and it should look something like this. Again, your pin electrical types might be different than mine. That's totally okay. In fact, probably safer if they're all passive, but again, it's completely up to you. I'm just demoing here. So next we're going to we're going to make the box to identify the symbol's outline. And basically that's saying that all of the pins that are kind of quote connected to this box are all tied together in this part, which is useful. So I generally recommend using the rectangle tool for this. You don't have to. Whatever shape you'd like to use, you can totally use. You could do a circle if you wanted to, or there's a line tool as well. You can use the line tool. No one is going to stop you. A box just happens to be a nice kind of convenient thing, and a lot of this stuff is done in boxes. Just make it big enough so that all 6 pins can kind of sit nicely around it. It's super easy to adjust. You just adjust the sizing of it later afterwards. You can just, again, click on it and just drag the corners. It's very straightforward. So I made mine like this. There's an algorithm here for how, or like a rationale for how I actually spec this size, but I basically abandoned this entirely in about 2 slides, so don't worry about that, and just frankly, you can ignore it. It's not always the best way to start making a box, but it is a good kind of option. If you don't like, as I mentioned, if you don't like how yours looks, just hit escape to exit the like rectangle mode, and then just click the corners to adjust, but it'll totally be fine as long as all of the pins fit. And next I'm going to suggest we're going to move all of the pins around the outline such that the line, the pin line, that red bit, touches the edge of the box with the pin name on the inside of the box and the little circle and the pin number on the outside of the box. Something like this. And I would suggest pausing the video here and place the other 5 pins around your box before seeing how I did it. You can also hit R to rotate. And just click and drag R to rotate. Again, it can all be adjusted later. So you might have made yours that looks something like this, with 3 pins on one side and 3 on the other. It's totally fine, nothing wrong with that. This is just grouping by pin number, so it looks similar to what the footprint might look like. It might be advantageous to group them instead by function. Perhaps you want inputs on one side, outputs on another. You might also make them all on the same side. Totally okay, not as traditional, but totally acceptable. I made mine mostly like this. Not mostly. I made mine like this. I kind of looked at the circuit itself and visualized that it was better this way. It'll be better for like wiring and connections, and it'll look cleaner. Frankly, I based this off of the earlier schematic circuit diagram that I drew in Draw.io that I showed at the beginning of this and all of these videos. It's functionally identical, but it's a little bit cleaner is mostly in the end. And you can also adjust it later. Like once you've placed it, you could have done a whole bunch of stuff. You can always go back into the symbol editor view and adjust it. Super easy to do. Additionally, when we learn about nets and wiring in the next video, you might understand why it doesn't really matter how the symbol is laid out so much, because pins can connect to any other pin or any other node without a direct line anyway. The important part here is that as long as all 6 pins are on the outer edges, it doesn't really matter. It's just aesthetics at that point. Great, so next we'll move on to moving the reference designator, that U that's sitting kind of in the middle on the left, to somewhere that makes a little bit more sense and won't be obstructed. Now remember that U is that reference designator. There'll be a little number next to it when you actually add it into the schematic. Often we add this to outside one of the 4 corners of the box, but it doesn't have to be there. Again, this is kind of up to you, stylistic preference. I'm going to go ahead and add mine to the top right, but wherever you want. Next, we're going to change the anchor point. This is the point, again, where the symbol will be kind of attached to your mouse pointer at, or anchored to. Usually the middle or the corner is a good choice. You can either do that by highlighting, left-click and drag the entire design and then moving it such that this big cross is your anchor point, or using this icon that's highlighted on the right and just clicking on a position. And you can see that big cross kind of moved down a little bit to indicate where that anchor point is. And lastly, what we want to do is open up the symbol properties window. So we're just going to double click anywhere in the canvas, or you can go to File, Symbol Properties to open up this library symbol properties window. Again, there's like the part 1 that we encountered in the last video. These windows have a lot of different options that are lots more flexibility, but we don't need most of that. For now, what we want is just to add the part number to the value field. So that's right below what's highlighted, the reference that's highlighted here. You can also add a footprint. You can specify a basic or a default footprint for this as well. In a different world, it might be valuable to actually, do that in this case, simply because this IC only has a single footprint. So it might be useful to kind of tie those two things together, but it's not important. You can always add it later or change it later. It's not that relevant. So you can see that I added the part number there to the value field, and just go ahead and click OK whenever you're done. And then we're going to move that part value to somewhere where it can be read. Again, typically this is either in the middle or on a corner. I'm going to move mine to the middle, and congratulations, that is the completed symbol. As I mentioned already at least twice in this video, you can always change it later by coming back to the symbol editor and editing away, no problem. Definitely do not forget to save all of your hard work. And finally, we can add the symbol directly into the schematic with this icon here, highlighted by pointed out by that nice little arrow. You can also just close the window and then add it through the add symbol menu or window. Also totally okay, just a shortcut. If we did find a model, let's go way back here. Remember that we searched for models and didn't find any. If we had found a model, you would obviously download it, so you'd get the symbol. Usually that's going to be in a zip file, and it'll contain a .KiCAD_SYM for symbol file. Make sure you unzip the zip file if it is a zip file. And then in your library editor, symbol editor here, you would right-click on the library and go to Import Symbol. Then you would navigate to that symbol file, you would load it, confirm the pins look good and the pin names and numbers are right, and then you would save it. Super straightforward. So I'll give you a few more minutes here, so I would pause the video shortly to arrange the schematics, something similar to this. It doesn't have to be exactly, but mine will look something like this, so if you're trying to follow along more exactly, definitely recommend doing that. Again, you don't have to do it this way. We're going to talk about how to connect pins together without wires in the next video, so if your stuff is all scattered around, we can still get away with that. It's not going to be a big deal. Remember that you can move parts by clicking and dragging on them. You can rotate them by clicking and hitting R, or mirroring but with X and Y. So go ahead and take some time to do that now. Fantastic. So your schematic, once you've moved everything around, should look something like this, vaguely. If it doesn't, it's totally okay. Definitely do not forget to save. Again, save frequently. You never know what's going to happen here. It's computers do silly things sometimes, and it's really tragic when you lose all of your work. You may have also noticed that my LEDs have all of a sudden become filled. I mentioned this in the last video, but there are a couple different symbols that are functionally identical for LEDs, and some of the other parts as well. And one of them is the LED filled symbol. Again, functionally identical. I just like the fact that it's filled. I think it looks a little bit better. So in the next video, we'll move on to wires, labels, and nets, which brings us to the end of part 4B, in which we covered locating device models online and making a symbol for the integrated circuit component. A PDF of this video is available as well, linked in the description and hosted on the Hive's Wiki. In the next video of the series, in part 4C, I'll teach you how to actually connect all of these components together. So see you then.